Hello and welcome to the wonderful world of databases. I'm your professor, Dr. Ron England, and this is the first lecture for Introduction to Database COP4708. So, let's start right off the bat talking about data. All right. Okay, we're going to start with a definition of data that you're going to hate. Values of quantitative and qualitative variables. All right, well, we just took data and we just broke it into two other large words. So what do we mean by quantitative and qualitative? Okay, first, let's talk about quantitative. Well, numbers should be pretty obvious that those are quantitative data. If you're collecting a set of numbers, let's say times or speeds or anything that's numbers, that's quantitative. Qualitative, well, we can say my opinion is very qualitative. Unless I'm a fixed group of people that only have a finite number of opinions, in which term I can make those quantitative. Okay, data is essentially everything. Everything can be data. It's just really what it is. Learning to understand and analyze data. We used to think of all the massive text in the world. Not really thinking of that as data. Well, now it's data because we've been able to take it, put it into AIs as data, and guess what? It is able to regurgitate it back up in formats that we didn't even expect. However, if you're going to be an IT professional and do this job, you're going to have to get good at something really important: organizing data. Okay, part of it. So, we got lots of data. There's lots of it. And again, like I can say, everything is data. Well, back in the old days, before computers, we kept data. We just kept it on paper. And the one thing about keeping data on paper was it was challenging. Okay, but at the same time, we did have ways of organizing the stuff that we put on paper in different ways. In the electronic world, we've got the ability to organize it in many ways, but we've also got a lot more options for the way that we manage and store it. But a lot of the management and store it practices that we came up back in those days before computers actually still apply today. So we digitize it. Now we got the ability to access it in all sorts of different ways, but we've also got the ability to analyze it in ways that we really didn't have in the past. Pretty cool. So there's a lot of companies out there that are pretty much driven by data. And when you look at these different types of companies, you would think like what? Amazon Prime or Amazon. Let's talk about Amazon. Amazon sells stuff. Okay, great. Is that data? Is that really a data-driven company? Oh, yes, it is, because they use the data about you to help them sell stuff and what people want and how to get it to you, and how to do it fast, and where to put the warehouse center so that they can do all these things. That's all data-driven stuff. And why does that make them a data-driven company rather than a company that sells stuff? Because without that, they don't have a competitive advantage that allows them to do the job that they do. Now, let's talk a little bit about big data. Little data, we can talk about all the time. It's pretty easy. Big data. Well, big data is when it gets big. That's pretty much the definition. It's large and complex. A lot of data, relatively complex data, lots of the data. And now we have the ability to store massive amounts of data, but we also have the ability to analyze massive amounts of data, which makes big data one of those things that's tremendously useful. In the past, big data was there, but it didn't have the usefulness as it has, I guess, today, because we got the ability to do stuff with it. Now, another thing to think about, the concept of information versus knowledge. Well, this is another one where the definition is absolutely great. Information is information. Oh, well, that is a horrible definition because, I mean, what does that actually mean? And how do you define that against knowledge? Well, knowledge is the ability to take those pieces of information and make meaningful, I guess you could say in this case, links, this is the way we do this, and apply it to do things, to make decisions. And really, knowledge is often extracted from information. And knowledge requires, and that's a good way to do it. Knowledge, I wouldn't say necessarily requires experience, but experience doesn't hurt. Information doesn't necessarily need experience. So I'm going to be asking the students to say, in your mind, what is the difference between knowledge and information? There's a lot of different ways to look at that. And you're going to discuss this. I want to give you a starting point for discussion. And I don't want to give you what my exact thoughts are on this because, and again, it takes away your ability to discover. But I think I've given you enough information to get you to where you need to get started. Structured versus unstructured data. This is one that you do need to know. When we organize the data, we give it structure. If you have disorganized data, or data that doesn't actually have a structure, just a bunch of words out there that aren't put in any type of method, that's unstructured. Okay, typically we'd say the text of a book is unstructured data. It actually does have a structure. Okay, because it wouldn't be something that you want to read if it just was a bunch of random words put onto pages. You wouldn't be interested in it. It has a structure. But it doesn't have a structure in the way that we define structured, that it's organized. If you took the same book and then you put every time a certain word occurred in that book and then just put the number of times it occurred, that would give it structure. And then it wouldn't be readable anymore. Okay, but you organize it, you make it structured. And we're going to talk about how you structure data because there's a lot of ways to do that. The one that we're really going to explore in this class is good old relational databases. But there's others. So I just said a relational database. So let's talk about a relational database. Why? Why do we use databases? Well, it helps us to retrieve and organize information. That's really it. And if you can organize and retrieve, it means that you've got the ability to get information rapidly. And that's something that we actually want to do. And we're talking about the concept of a relational database. We can talk about the concept of tables and fields and records. And you can think of it as a table as a collection of fields. Or you can also think of it as a collection of records. But the reality is it's a collection of both. You have fields that are essentially, in this case, the columns, and you have the records, which in this case are essentially the row, excluding the first row, because that's just the title of each of the fields, and that's data. And that's how this type of database, a relational database, is organized. When we put this together, we've got different ways of looking at the data. Is there a relationship that this piece of data is a one-to-one relationship with another piece of data? Is this piece of information, let's say a social security number, which defines a single individual? So in the case of a database, you could say, let's use the social security number to identify all those other fields that go with that, except that we don't, because we don't use social security numbers for anything. But we can come up with other numbers that would be equivalent. Okay, that's the concepts. But when you're doing databases, and the beauty of a relational database is it allows us to take care of relationships that are one-to-one, one-to-many, and many-to-many. We're going to talk about that a lot in the future because that is the crux of database design, and you're going to need to know how to do this. Let me repeat that. One-to-one, one-to-many, and many-to-many. The relationships between different types of data and how to organize them. Now, you need a tool to organize them, so we have database management systems. We're not just going to throw everything into tables. We've got to throw them into tables. We've got to make sure that we can go to the tables that we want to go to, access a piece of information that we want to do it. We want to be able to do them securely. We want to be able to create. We want to manipulate. We want to manipulate the data. We want to manipulate the tables. Da, 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 da. That's the database management system, and there's some good ones out there. And for this class, you're going to be using Oracle. For the next class, if you take it 4709, you're going to be using SQL Server. And there's a few others that you will really want to play with if you're planning on going into the world of databases, which is actually a great world. So the components, you have the database, where the stuff is being stored. That's the tables behind everything. Then you have a database management system, which actually allows you to manipulate the database. Then you have potentially a language that allows you to interact with the DBMS to manipulate the data. And the common one that we use here is SQL, or Structured Query Language. And then you build applications on top of the SQL, and then the users use the applications. There's a lot. Just love it. It's great stuff. So the database applications. You use database applications. You're probably using one for this class right now. It's called Falcon Online. If you're using Falcon Online, or if you're just watching this video because you love it, if you're one of my students, you're using Falcon Online. You may say, well, that's the course system. Yeah, it's a database application, at its heart. That's what it does. All right, forms. I'm not going to talk about these yet, but that's a way to get information into and out of the database, and a lot of you are going to be building this. Queries, that's how you get the information. Okay, reports. Well, reports are wonderful because it allows you to get the information in ways that are useful to you. These are all parts of the database management system. Okay, the DBMS. Okay, the DBMS does all this stuff. Now, on the application side, it's going to look a lot like what the DBMS does, but it's got an interface that's designed for what we call end users. Okay, however, if you're taking this class, odds are you're going to be beyond the end user. You're going to be a person that actually manages the database. So all these things that you might need to do, making tables, adding stuff to the tables, making direct edits, looking at the structure, setting up rules for the database, controlling concurrency or multiple databases working together, making sure the whole thing is secure, and also making sure that the whole thing is backed up and recovered when you need to do this. So, guess what? The database is an amazing thing. And the one thing I love about databases is that they store the description of themselves in the database. So the database doesn't necessarily know what it is, but the description of what the database is in the database. So it's a self-describing structure. And one of the other pieces of the there's two pieces of the self-describing structure. One is you can just look at the data, and you probably know the structure of the database. Okay, well that in itself is a self-describing feature, but we do put metadata on top of this, which is data about data. Well, what's data about data? Well, data about data might be, hey, when was this record created? If it's not in the database, it still might be being stored by the database management system, and it's metadata. What's the name of a table? That's metadata. What's the name of the database? That's metadata. Data about data. It's not the data itself, but it describes information about the data. And guess what? The metadata is also stored in the database in tables. Yes, that's the beauty of databases. It's all built into the concept of the database tables, and you'll learn how to actually query the database to get the metadata, which essentially you do all the time. And then there's the content. Now, content goes beyond just data. Okay, you've got the metadata, which is also database content, but there's things like indexes. Well, what are indexes? Well, if you got billions of records, indexes make it much easier to look for information in those billions of records. Stored procedures you aren't going to do in this class. You do that in 4709, but you can actually write small computer programs call them functions. They're called stored procedures that allow you to access the data in specific ways, which is beyond views, which I, by the way, don't have on this slide. Triggers. If something happens in a database, you can cause something else to happen. I'm not a fan of triggers, but it's there. And you've also got security built into the content itself and the ability to back up and recover and actually store the information about the backup and recovery in the database. Wow, it's pretty cool. So looking at different databases that are out there, Microsoft Access, which is a very nice little database. It's a desktop database. It does a lot of things that are very useful to it, but it's not a big database. It's not designed to hold billions of records. It's not designed to be used by millions of users, whereas other databases are, some of the big ones. However, the more power you get, the more complex you get. But that makes sense because if you're managing billions of records, you want to make sure that you're doing it well. Okay, Access, guess what? Not going to use it. MySQL, free, open source, popular. You can go out and get it and use behind such great things as WordPress. It's got, the PHP admin tool that comes with it is quite good. It's relatively easy to use. I use it all the time. I use SQL Server all the time. Most of my professional work is done in SQL Server. Some of it's also done in Oracle. And I really do like to stick to both SQL Server and Oracle for my consulting and professional work. DB2, I don't use it all the time because, well, it's a little bit of overkill and just not one of the ones I really use a lot. Oracle, yes, I use it. I've done many systems in Oracle, and Oracle's also got some of the best third-party tools to go with it that I've ever seen. Designing the database. All right, so how do you design a database? We're just kind of going to glance because you're going to be doing it. First thing you might want to design the database is simply by looking at the data and designing it around the data itself. This may be a great process. It may not work out for you, but it is the start of almost every database design. Okay, suppose you don't have any data. Well, you can still design a database to look at and work with the data that you might potentially have. Okay, create the data, you create the model from what it is that you need to do. Okay, and redesign. This is the one that actually, if you're going to be a database consultant, it's the one that pays the best because there's a lot of legacy databases out there that need to be redesigned. That's just part of it. So all the effort of redesigning it and migrating the old data into the new system and cleaning up the data from the existing system is something that you could be doing. Or you could be taking multiple databases, putting them together into a single database. Or you could be taking a single database and breaking out into multiple other databases. These are all things that are part of database design. The language of databases, structured query language, SQL, we all call it SQL. Okay, it might be pretty obvious why. And I always say, SQL isn't original. It's a joke. It's a dad joke. Anyway, it is a language that you use to build databases, build tables, but also a language that you use to manipulate data, and it's the most powerful querying language that there is. And you know what? It's used by almost all database management systems in its common form, and it's pretty easy to look at SQL statements and tell what they're doing. Okay. NoSQL. Well, one of the popular things today is good old NoSQL. But the thing about NoSQL is that it has a lot of limitations that we will also again talk about later that SQL databases don't have. One of the biggies being it can't model many-to-many relationships. It's essentially a flat file. That's what we call these things, flat file databases. It's not exactly flat file because it does allow a many-to-one relationship, but for many applications where you don't care about that complexity, it works quite well and they're simple. That's a beauty. What can you do as a database? Well, here's a few things, one of which, programmers and developers of databases are a different job from administrators of databases, though administrators often do have to be able to do some database programming. And database desktop support is something totally different from all the others. The DBA, Database Administrator, is one of the most important jobs in almost every company that uses data. Keys to the kingdom. Companies live by the data they have. It's just the reality of the data life today. Okay, questions? Well, guess what? I get to ask you guys questions because your homework assignment is going to have you take what I just told you and expound upon it by doing some queries of your own. So enjoy this semester, and this should hopefully get you started in the great world of databases. See you later.